Well, maybe we can try just quickly if Kai and Arid can share their screen. And if everything works, then we can start the recording. Do you mind trying to share the screen if it is possible?
It just told me that it's deactivated.
Yeah, Alberto?
Yep. Now is okay.
Yeah. So this could work.
Very nice, I would say.
Okay.
So, Kai, we can see your slides. And Arit?
Yeah, my slide is visible?
Yeah,
Okay.
perfect. Very nice. So I would stop. Yeah, perfect. And I will share my slides. And I won't see you anymore when I started sharing. So, okay, here we go. And once again, thanks for joining today for this 10th webinar of the Technical Talks of CTSoc series. I just want to provide you with a quick overview of the context in which this webinars are organized as a Vice President of Technical Activities of CTSoc, IEEE Consumer Technology Society. So CTSoc is active on a number of areas as all the other IEEE societies, like conferences, publications, standards, and there's a technical activities area, and these areas is in charge, of course, of the technical actions taking place in the society. And this area is organized mainly in 15 technical committees. These technical committees have been established in January 2020, end of December 2020, and they cover the broad spectrum of areas of interest for the academia and industries in the consumer technology society. So as you can see, these technical committees span smart cities, audio video signal processing, automotive applications. Today, we do have two technical committees responsible for organizing this webinar, which are the security and privacy of consumer electronic hardware and software system, the SPC+ENT, and the entertainment and gaming technical committee. So we decided to have these joint webinars because it's nice ways to combining different topics in the same talk. So attracting different people with different backgrounds and interests. These areas, the technical activities areas, also has a future directions committee and is governed by a technical committee board. Each technical committee has its own website with mission and objective, with the officers, with the list of members. And regarding the officers, these are the officers for the 2023-2024 term. And just as an information, the elections for the 2025-2026 term will begin soon. So in case you are interested in nominating, so you will receive information. If you are a member of the technical committees, you will be receiving information soon. Otherwise, you can join our technical committees. In order to join, well, there are a number of ways, but the easiest way could be going on the main website of CTSoc, check the technical activities areas tab, and under this tab, you will find the technical committee's membership application form. You fill in the form, and the technical committee's officer will review your application. At this time, you don't need to be a member of CTSoc or IEEE to be a member of the technical committees. These are the members. It is a subset of IEEE CTSoc members, in the sense that not all IEEE members are yet members of the technical committees, but we have many members of the technical committees who are not members of IEEE or IEEE CTSoc. Maybe they are interested in our conferences, in our publication and stuff like that. You see that These committees are growing in different ways because they are following, of course, the trends, the major trends, and we are waiting for you to join as well. Why? Because the technical committees are supposed to support CTSoc and the society in general in all areas of interest, so conferences, publications, standards, education, and history. So, for instance, they are involved in the definition of the call for paper of conferences. They are providing members of the committees, reviewers for the conferences. They have a number of roles in any areas of CTSoc. Just to provide you an example, they are supporting with providing names for associate editor positions. They are organizing special sessions in journals, and some of our journals request you to be a members of the technical committees to propose a special section. They are involved in other initiatives that are moving around CTSoc and IEEE. They are organizing special interest groups. They are participating to funded projects by projects funded by CTSoc, like student internships. This is a very recent initiative. So if you want to get informed, get updated on what is going on, there's a page of CTSoc website under technical activities named Outcomes and Opportunities, where you can see open opportunities and results that have been achieved already. One interesting initiative that is being shaped around the CTSoc is the digital reality technical community. So this is not a technical committee, it's something broader. It's not managed at the CTSoc level, but is involving other societies like Reliability Society, Electronic Packaging Society, Engineering and Medicine and Biology Society, IEEE Councils on Radio Frequency Identification, IEEE Standard Association, IEEE Robotics and Automation Society. We are talking with other societies like Communication Society. They agreed already to sponsor. So we will be seeking your contribution and the contribution of the technical committees in leading this initiative. You know, this initiative is about digital reality, which is a term which encompasses digital twins, extended reality technology, communication. So, of course, there are many aspects related also to security and privacy, entertainment, and stuff like that. For instance, there's a conference at the third edition, is the International Conference on Intelligent Reality. This is organized by the DRTC, the Digital Reality Technical Community, will be held in Coimbra, Portugal on December 5 and 6 this year. So if you are interested, please submit. There is a call for paper open till October 4th. I think that's it. So talking about the technical talks, this is the 10th webinar. Every month or 2 months, two technical committees are collaborating to identify the speakers and bring interesting topics for our members and IEEE in general. This month, the technical committee is being organized by the SPC. The technical talk is organized by the SPC and the ENT technical committee. So, well, this is my last slide. Before leaving our moderators, and I thank again the moderators, of course, Professor Alireza Yolfaei and Kia Mu for having helped with Kaya Renly to organize, Professor Kaya Renly to organize this talk. I leave you with this slide. I leave the floor to my colleagues for introducing the speakers, and I want to thank again Dr. Harihit Karati and Professor Kaya Renly for their talks today.
Yeah, thank you, Fabrizio, and thank you, everyone. and welcome to our September talk series organized by CTSoc. So as Professor Fabrizio Lamberti mentioned, we have two interesting talks today. So the first one is a distinguished talk from CTSoc. So for today's talk, we have Professor Arijit Karati from National Sun Yat-sen University from Taiwan. And he's going to talk about on a very topical area of role of cryptography in mitigating security vulnerabilities of a space information network. Thank you, Professor Karati, for being with us today. We are all ears, and we would be more than happy to listen to your interesting talk. So I leave the floor to you so you can start your talk.
Okay. Okay. So thank you, Eliza, for a nice introduction. Okay. So good day, everyone. Today we are going to discuss about a topic mainly emphasizing the role of cryptography in mitigating some security vulnerabilities of space information network. So as we know that satellite communication is getting emerge day by day. So the space information network actually has lots of opportunities in terms of integrating some IoT commercializations and their communications. And we may have some kind of continuous services with the help of space-based communication, like satellite-based communication. Indeed, in this way, we can actually enlarge the communication area. At the same time, it is possible that we may also raise some safety and privacy concerns. So more importantly, we can say that like improper protocol execution and exposed links lead to unauthorized misuse of network resources. So the talk mainly explore about this user-centric safety concerns and proposes some solutions in cryptographic means. Okay, so here is the content of this talk. So first we'll explore the space information network and its potential threats, and then we'll try to highlight some of the security threats that could be solved through user-centric authentication. So overview of space information network. So here you can see like the satellite communication basically involves the use of satellites in orbit to transmit as well as receive some radio frequency signals across various parts of the world. So here the space technology recently has become more affordable and getting more effective nowadays. And it may provide many different kind of services. For example, like Earth observation, remote sensing, IoT data collections, space-based cloud, and asset tracking as well. So here, the recent trends are towards establishing the satellite communication infrastructure system with growing B5G 6G network. According to latest release by 3GPP, developing 5G systems to support non-terrestrial network, that is the satellite-based communication, has been an active research area, and it may have many future possibilities in terms of communication. At the same time, the security incorporation in such kind of network. So if we see the history of satellite communication during 1950s to 1980s, the international business communication services gradually expanded based on evaluation of international satellites, Intelsat. And the turning point came around 1990s, the inventions of constellations of narrowband satellites signed the commercialization as well as the privatization. And if we see the current market scenarios in space communications or satellite communication, so here we can see the market size is around 90 billion in 2023, and it is expected to be 188 billion in 2031 with a CAGR 9.6, which is quite like impressive. And integrating the latest 5G network with communication satellite is also called as 5G satellite communication. And recently, many countries, they have already started spending their money to develop these satellite-based communication, which is like non-terrestrial communication, how we can integrate with terrestrial network to have better communication as well as remote access. So the incorporation of satellites will also open the door to implementing virtual networks and providing more customized connection to meet ubiquity, mobility, as well as the security. And in this part, actually, top player companies are Inmarsat Global Limited, ACS, Avanti Communication, Global Stars, and so on. So here we can see a brief overview or something like high-level overview, which talks about integration of terrestrial network with non-terrestrial network or space communication. Here, the space technologies are typically divided into 3 different groups based on their operating orbit altitude. Geosynchronous Earth orbit, that is geo satellite, medium Earth orbit, which is also known as MEO, low Earth orbit, which is also known as LEO satellites. So a satellite in geosynchronous orbit stays over the same spot on the Earth, so their movement is negligible compared to LEO or MEO satellite. Here, the MEO satellites typically, MEO satellite orbit is around like 2,000 to 20,000 kilometers above the sea level, while the LEO satellites are typically below 2,000 kilometers. However, the interesting point is that is the round trip delay. So here the LEO has the less round trip delay, which is around 240 milliseconds compared to MEO, like 550 milliseconds. So here actually comes the communication scenario. So we can take the advantage of LEO satellites because it has like less round trip delay. So based on these LEO satellites and their communication, we may have some kind of access or services. We can get some remote services via connecting this ground station. Okay, so basically, LEO satellites perform scientific data exchange. On the other hand, MEO satellites are mainly used for navigation and spatial data exchange. So in typical situation, how these LEO satellites actually get connected and can give you the services, the connection is very typical. So here you can see that if we consider these are some kind of endpoints for the user who is trying to get some services with the help of this LEO satellite. So obviously we may have some kind of NSS satellite communication satellites that module should be enabled on your mobile devices to which you can connect the satellites, and the satellite will connect to the ground station, and this ground station typically connects to the core network. So in this way, like one EV can get the services with the help of satellite. So according to this 3GPP version, release version 16, we can find out like there are different kind of satellites like GEO, like HAPS, like LEO, MEO, and GEO, based on different kind of altitude from the sea level and their communication range or like beam footprint size. And here in this talk, we are mainly focusing on locking these satellites like LEO and HAPS kind of like which is near to Earth, and we are trying to communicate with them. Okay, so according to this 3GPP release, like a recently released, we can find out like it is also possible that we can integrate this CAT-M and NB IoT, like narrowband IoT, with non-terrestrial network like NTN networks, provided that this UE should have some kind of support of GNSS functionalities, so that this UE can connect with the satellites with the help of service link or the user link, that is also called as user link, and then the satellite may connect with this gateway to this feeder link, and this gateway may be connected with this core networks to give the user some kind of services, remote services. So in release version 17, 3GPP also has approved the solution for converting this CAT-M and NBM to enable this NTN. And also in recent release, like release version 18, one hot topic is like how we can intricate like network verified EV location, how we can share with the help of this NTN network. So there are many identifying requirements and use cases are being under consideration. So here we are going to discuss a very straightforward aspect because we are focusing on the cryptography. So here the case study is mainly highlighting this eavesdropping attack from the user equipment perspective. So eavesdropping is nothing but, as we have seen the last figure in the last slide, like user can connect with the satellite with this service link, and the satellite can connect with the gateway ground station with feeder link. And during these two communications, is it possible that possible for the attacker to compromise those communications, and is it possible to get some kind of user personal information or some satellite specific information or not? So if an attacker can able to get those data, so it is comes under like this eavesdropping or like some kind of snooping, and then it is actually able to get those realistic data. Okay, so while we are talking about like cryptography in this satellites point of view, cryptography can fit in these authentication scenarios, and authentication may take place in this handover scenario. So what is this handover here? We can see. So there are three different kind of figures here. We can see that is the first one is like satellite only handover. The second one would be like the ground station only handover, means we are switching different ground stations to get the services, and another scenario is like satellite and ground station handover, like both the handover. So today we are actually focusing on the first part. So here what we are actually seeing, for example, a satellite is moving, the current satellite is moving with a velocity v towards this direction, and one user is moving towards this direction, so like the EV, for example. And there is obviously one ground station is there. So EV can get the services with the help of these satellites from this ground station, and user can connect with its device. It can connect with the satellites, and satellite will connect with this GS, and then we are giving some services related. For example, we are giving some kind of remote data access on some services. Now it is possible, since it is moving, keeps on moving towards this direction. And for example, user is moving with less speed, for example, towards this direction. After some time, it is possible that this satellite may be not in the range of this communications for this user, so it is moving out. So if such kind of situations may occur, then it is possible that we are not getting any services with the help of these satellites because of this communication range, and another new satellite may comes into this picture based on this constellation, like satellite constellation. And what will happen? So this is the next scenario. Here, the user is getting the services from the new satellites, where this new satellite is connected with this ground station. So in this kind of handover scenarios, authentication takes a huge role. The reason is that first is the location could be like user's location could not be traced. At the same time, satellite personal information cannot be cannot be traced. And once this satellite is moving towards, for example, leaving this range, the new satellite comes into the picture. So it is possible that this satellite is sending some user-specific information, obviously some privacy preserved technique, um, to the satellite via this inter-satellite link, that is ISA. So in such kind of communication scenarios, we can identify some set of security and privacy challenges which can be solved with, using some cryptographic protocol. Okay, so here we are only highlighting the cryptographic perspective. It could have some kind of network related issues as well. Okay, so basic in this communication, so this is the communication pattern that we have just discussed, and in this particular communication pattern, we may have some kind of very specific security properties. For example, mutual authentication between the satellites, at the same time the ground station, conditional anonymity is quite useful for the UE's point of view, because UE's the location should not be traced, and some personal information should not be traced during these two communications. Like while some kind of authentication token is being exchanged between several entities, some personal leakage should not be there. Similarly, communication unlinkability, like a randomness, is required, and some forward-backward secrecy in terms of cryptographic keys. And it is possible, like the EV is trying to actually breach the services. For example, it is not a subscribed user to have some kind of services. However, it is getting the services by bypassing those communications. So once it is identified, it is possible that we can revoke that user. So how we can do that thing using cryptography. And also, with the help of this, like while you're discussing about this security threat, it is possible that we may also deal with some kind of security attacks. For example, this quantum attack is quite getting very popular in nowadays, and it will be maybe huge aspect in the near future. So quantum attack, quantum computations, or quantum computing capabilities. If we consider this kind of computations into the scenarios, then obviously those public key crypto systems will be vulnerable. So how we can design some cryptographic protocol which can also resist some quantum attacks. At the same time, the communication replay should not be there, and the spoofing or the impersonation should be avoided for the UE's point of view. And the man-in-the-middle attacks of service disruption could be also achieved with the help of this strong cryptographic design. Now, sustainability is also another quite like hype recent days. Like according to a couple of research papers recently published, here they have mentioned like we can have many other factors to achieve the sustainability, but there are three of them I just have mentioned over here, like the economical, like cost effective, society usefulness, and environment friendly. However, cryptography doesn't have any role in achieving, like much role in achieving all those aspects in sustainability. However, it is possible that we can design some lightweight cryptographic schemes, which is much more economical and cost effective. And the second one, it could be like, can we design some kind of scheme which means which is secure for long term? Okay, it's not like we are keeps on changing those security protocol. Means it has some lifelong usability. So if we can do that, then maybe some part of sustainability we can also achieve using this cryptographic protocol. Okay, so while you're discussing about this cryptography, so mainly authentication context, cryptography can help you to give some kind of trustworthy data transmission. Okay. Transmission and the granular access control, as well as the device authentication. Okay, so what are the cryptographic techniques we can assume or we can consider to design or to mitigate some kind of security attacks that we have discussed? It is possible, like when you're talking about the quantum attacks, we can design some lattice-based cryptography or lattice-based trapdoors to resist those quantum attacks. To mitigate those replay attacks, it is possible that we can use some non-spaced cryptographic techniques over timestamp-based techniques, because in satellite communication, we have some round trip, or we have some kind of indeed delay threshold we have to consider. So we can use this non-spaced over timestamp-based. And also we can have some kind of strong authentication as well as the robust key management to resist identity theft, impersonation, and forward and backward secrecy. Okay, so for user revocation, yeah, cryptography also have some kind of role by mentioning some kind of cryptographic tokens in terms of public keys of users in centralized or distributed order, so that we can find out, okay, so if this information is already listed out in that particular list, then we cannot accept any communication from such devices. Okay, and also this is another kind of device oriented authentication, UE specific authentication, by utilizing some kind of hardware features, by utilizing, for example, physically unclonable functions. Okay, so I briefly highlight one of our works recently because we don't have much time. So this is one work where we actually achieved some of those security features that we have just discussed. It is recently like published in the Proceedings of International Conference on Security and Cryptography. So yeah, so we don't have much time to discuss this communication protocol in detail, but I can give you the basic idea. So here we actually we have mentioned all those cryptographic primitives that we have used in this protocol, and this is the basic protocol. So here each and every entity, they do have some kind of secret key as well as the public key combination. The user is getting services first from the satellite, and satellite is connected with this ground station. And once it is coming out of the range, the new satellite comes into this picture. And uh, here, this satellite is sending some list of users, active users details that you can see here via this ISL, inter-satellite link. Okay, so here you can find out these satellites now have like better list because now the satellite knows that what are my active users, and from this list it can try to identify this user without having the re-authentication. So I hope you get the idea. Like re-authentication is time-consuming operation. So how we can switch the session from one satellite to another session without re-authenticating the user, but indeed, we should have some kind of common secret, so that we have already mentioned over here. Okay, so if we can have, then we no need for re-authentication. Okay, so for this, we have achieved some kind of security features. For example, it is secure against quantum day, like quantum safety, like Q-day safe protocol. Authentication protocol, it has higher level of security or the safety level. It is mainly based on Girault level 2 safety. It does have some kind of fast handover authentication that we have said, because this list is designed based on hash properties. And also we have some kind of mutual authentication. Here the mutual authentication in terms of satellite and user and ground station, both this mutual authentication should be there. And strong session key agreement and forward backward secret keys and user privacy we have maintained, because during this communication we never expose any private public information, we never disclose any secret sensitive information. For example, user key, user personal credential, or satellite specific information, all are encrypted, so privacy has been maintained. And also some other network attacks also have been resisted. Okay, so now we are recently we are doing some kind of ongoing work, and that could be also considered as open problem. So basically, in that the work that we have discussed, that is mainly talking about semi-trust region. So how we can adopt this zero trust architecture in this particular satellite-based communication, so that we no longer trust, like user no longer need to trust any kind of third party for their secret keys. And also in that work we have just discussed like a single NCC framework, like network control center, based on different region across the globe. We may have multiple region. So if we consider multiple region, then what should be the communication protocol will be, that could be one interesting problem. And once we are talking about zero trust actually environment, then their key management will be typically different compared to the one which is semi-trust environment. And also we are talking about recently like how we can develop, how we can integrate that IoT with this NTN platform for lightweight devices. Can we design some kind of lightweight physical layer security PLF for Z, like zero energy device, very lightweight communication and their devices. And also there could be another open problem, could be like quantum satellites, energy efficient QKD through satellites, because as we know that in 2016, first quantum satellite is launched by the Chinese Academy of Sciences, something to test the transfer of quantum information between space and Earth. And similarly, next year, Canadian Space Agency also launched some kind of initiative to study these quantum links and quantum key distribution. Okay, so without taking much time, I think I took a little bit more time. So without taking much time, so I conclude here. So I'd like to thank everyone for joining me for more discussions on cryptography or security solutions in space communication context. you're welcome to connect me via arijit.karathi at csc.nsycu.edu.taiwan. Thank you very much.
Thank you, Professor Karati, for your very interesting talk and informative talk on satellite communications and cryptography aspects to it. Do we have any question from Professor Karati?
Yeah, I have one question. So, hi, can you hear me?
Yeah. Hello. Yeah, I
Oh,
can hear you.
okay. So actually, I'm not the expert from the space information network. So, but I'm wondering whether the Starlink from the Elon Musk belongs one kind of space information network, and do we need to worry about the kind of security of Starlink? Do you have any comment?
Yeah, okay, so that's quite a good observation because there are two different types of satellite communication. So here we mainly focused on like a beam footprint where we don't have any 5G access to the satellite. So typically here the user connects to satellites, satellite connects to the ground station, and then the ground station has that access for the core network. This is another one kind of communication in the satellite. There is another kind of communication which actually comes under the Starlink, where the user directly connects to the satellite, and satellite also carries some kind of 5G systems, which through which it can directly connect to the core network without connecting the ground network further. So while you're talking about this Starlink based communication, we do there is nothing like a scary kind of thing, but we do need to consider this quantum aspect in near future, like how we can mitigate, because the Starlinks also do they does some kind of that, some public key crypto systems they include in their security mechanism. So it is also quite useful if we can migrate those traditional public key crypto systems that are being used there to some quantum resistant approaches, and that is our main goal. And I also introduced the same thing, whether we can migrate those approaches towards the quantum safe solution. Yeah.
Yeah, so the kind of quantum secure cryptography has been a standard for this satellite communication or even 6G communication
Yes.
standard that has been included in the standard, right?
Yeah. Because NIST, I think all of us we aware that last month NIST has published some post-quantum cryptography based three solutions. One is modular lattice-based uh, digital signature, stateless digital signatures provided in three different standards like FIPS 203, 204, and 205. And they have said like that we can use those primitives to design authentication protocol for quantum resistant algorithms. So they have also taken some kind of initiatives for designing some low-level primitives so that we can use those things to build up our own protocol to address some of those security issues. Yeah.
Okay, I got it. Okay, I have no further questions.
Okay. Sure.
Yep.
Thank you.
Yep. Thank you, Professor Karati. Seems
Thank you.
there is no other question from our audience. Just a very quick question from my end. Just wanted to know if you want to do your experimentations, do you have access to a real satellite? The reason why I'm asking, I have a colleague here in Australia, a research on satellite communication, and she tells me most of the time she just come up with idea coming from her imaginations, and just wanted to know. I mean, you
Okay.
are from a different country. Do you have access to some of those?
Okay. No, so to be frank, we don't have any real satellite connection so far, or some kind of access to real satellites. So basically, what we are doing right now, we are trying to develop those protocols, and we are trying to test it whether those protocol itself secure or not. So we are now in testing phase, once it will be successfully tested for many different cases with some kind of success score, then we may adopt those kind of protocols. Yeah. But so far, right now, we don't have any access. We are just considering the roaming situation. Any kind of roaming situations, if we can apply, then can we design such kind of algorithms which could be useful? Yeah.
Thank you very much, Professor Karati, for shedding light on us on this very important and topical area of cryptography and satellite communication. Thank you, Kiamu, for organizing this talk. So without further ado, perhaps you can start introducing our next guest speaker from the Technical Committee on Entertainment and Gaming, Professor Kai Ehrenli from the University of Applied Sciences from Vienna. So Professor Ehrenli has been very kind to us, and he will share his research insights on navigating the legal landscape of artificial intelligence in games and interactive media, with a view towards the challenges and opportunities. Thank you, Professor Ehrenli, for accepting to deliver this distinguished talk for the Consumer Technology Society. If you're ready, I leave the floor to you so you can share your research insights with all our members of the society. Thank you again, and thank you, Professor Karati, for your talk.
Okay, so thank you so much. I think we will have like 15 minutes left. That won't be very sufficient to be honest to talk about a lot of stuff. Usually I give lectures about this and workshops which last half a day, so it was quite tough to do this like under 30 minutes. 15 minutes won't do us any good. I will try my best. Just for a disclaimer for those people who might see the recordings, there are a lot of slides, and I opted for a lot of slides so you can see and read anything at your own pace. So don't worry if the guys online and live attending think, oh, this is a lot of text. Yes, it is, but it's meant to be this way. And I will guide you through that. So let's start with the connecting part real quick with the advertisement, so you know who I am and what I do, because that might help. I'm the director of interactive media and games business here in Vienna, so we focus on the business sides. I must say I'm a lawyer, so the research I do is not as sophisticated as what we just heard from Arijit. But the stuff that we lawyers do is less research, but more evaluation. But as AI comes our way, it kind of tends to be research. So let's look into this. So I'm also have like an industry head. I'm working as a general counsel for an animation studio here in Vienna. We do feature film. So if you want to talk about that, please reach out. If you want to do a feature film, just let us know. We do normal VFX stuff, and we do ads and game trailers. So that's the stuff that we do. On an academic side, I'm also a board member for iLearn, which is the immersive learning and research network. And I look into the VR field or the immersive field of, well, the industry. We have gathered more than 3,000 projects. We have like a list, which is more or less like an IMDb Pro for VR projects. And we disseminate that academically. So if you want to read something about that, that's in the paper. So just that you know that I do stuff in the industry. I'm not just here for the legal part. I also kind of tend to do digital humanism stuff. So I kind of draft the Bill of Rights too, so that we have some more common ground or more like etiquettes or guidelines to use for, everyone who uses the internet. Therefore, I'm also part of a project which is the Open Web Index project, and where we try to establish like an open web index for everyone. It's a European funded project, And it's also interesting that it will be able that you can build your own large language models based on this index. It's about to go public 2025-ish. But for now, we have crawled like a third of the internet, and it's ongoing. So looking at this, let's hop into the topic. So for today, my whole research, my teaching, my business was disrupted by generative AI. We have been using AI like in my business at the gaming industry. We've been using that for decades now, right? But as we all know, now our students are using it like at large, and we have to deal with it. So yeah, that's why I had to look into that as well. So there's another day of it depends. That's unfortunate, but you will see why it will be that way. And thanks for being here. So here in Europe, we had like this big announcement that the AI Act is entering into force. This is one of the first regulations that we have worldwide regarding AI in general. So that's something that we have to look into. There is no case law yet about this. So it's kind of research and yeah, well, some feelings about it that I can share. So it's gonna be in a nutshell. For a course about social media, I asked ChatGPT, does it make sense to use AI for social media posts? So it gave me a couple of items that it found useful. And I thought, so what about the legal aspects? Let's make this applied. So we have to start, of course, with content creation. That's something that it should be a good start. So you will learn a German term right now, which will be Urheberrecht and AI. Why do I need that? Because you will see that we have to talk about copyright and Urheberrecht. So just that we will have to start here so that you will get a gist where like the basic problems of AI and law are. So while you can see in the upper part that copyright derives from like the ancient term copyright, the right to copy something. So the king basically granted the right to someone to be able or eligible to copy something. So it was a kind of censorship. So it had nothing to do with like IP stuff. While the Urheberrecht, which derives from the French version, the droit d'auteur, which means the right of the author, kind of is connected to the work itself. So in the upper part, it's connected to the exploitation of a right, and the lower part is directed at the author to the person. So that's a whole different system. And that's one thing that kind of is a problem. I kind of tell my students that we don't want to use the term copyright, even though my whole industry is English. But it kind of misses the point that we have here in continental Europe. So therefore, just be advised, we are looking at two systems, and we might need this in a couple of minutes when we talk about that. So basic of copyright law means you have substantive copyright, which is the right of the author, the researcher, the composer, visual artist, and so on. And we have ancillary copyright. So this is the right of the performers. So this is something that we need to understand to be able to kind of cluster the problems around AI. So for example, AI generated image, of course, we have person and we have machines and system that are able to generate images, and we have the performers who are on stage who are who are gaining those ancillary copyrights. We need this because we know about this. Lawyers know about this. So this is something that we are quite familiar with. This is basic standard copyright law. And if you ask those copyright lawyers, what about the systems? They will tell you, well, we don't know. The system cannot gain any copyright. So if you look any further, this is now the German version of it, but still it is the same in most jurisdictions worldwide. We have the Berne Convention. We have all different things that harmonize this. So therefore, I just use this as an explanation. But the less peculiar work is the more likely is that slight deviations are sufficient to move away from the original. So if I draw like a smiley face, and some of you will add some hair to it, maybe some more detail, you might get a co-creation, or no one will see my original smiley anymore, and you will be the owner of the new one. So that will be important if we look into AI stuff. And then one thing, creation has to be based on a human thought process. So this is something that we know from the beginning. So we don't offer any copyright to animals. We had like a monkey who in our zoo here in Vienna who was able to paint pictures, but nevertheless didn't gain any copyright. We even have cases, for example, we have Tala with Perlmutter from the US that states pretty simple and clear that a machine cannot gain a human copyright registration. And but also it can be spontaneous. So if we think about, if I would just burst out and painting something on the wall behind me, that would be protected, of course. So let's go into this. So for example, if we prompt something that we want to write an invitation for an online course, because, well, it's far easier to let the system do it. This is no copyrighted work because we are merely the initiator of the creation. We just tell the system what to do, and also the system itself is too indirectly involved into this, so there won't be any copyright. So for my business, this is why I want to show you that I'm working for a studio. It would be far too easy to use generative AI, but then we want to hold on to our IP. But if we don't have any IP, that's no good because we cannot exploit that. So that's a problem that we have. Furthermore, if we prompt something into the system, this is a reproduction of the work. We would need permission. Here in Europe, you would need permission. In the US, not so much. We're gonna cover this, just keeping track of the time, of course. So if you want to do something in a university context for your research, if you want to maybe submit a paper or maybe just double check a paper, that might be something that the AI might be capable of doing. If you want to kind of have a look at the structure, maybe at the wording, please keep in mind that it's a reproduction. If that's your work, you are permitted to do that, but then please have a look at the terms of service or the end user license agreement, that this might be stored in there, and the system might learn from. So that's something that you have to keep in mind. So this is a long text as well. I'm gonna show it to you that you can read at home. That's going to be your homework. So training data. So I told you that this is a problem that that we face here in Europe, for example, because we don't have fair use. So OpenAI, when they were asked how they trained their system, they just basically said, we read everything it could, or it read everything it could access. So books, journals, blogs, forums, anything. But there's no like label that kind of tells you this is copyrighted or this is IP content. So it just gathered everything. And that could be a problem because it's not very transparent about that. So that's a problem. So we also know that they didn't document anything. So yeah, that's the problem that we have. So however, until we have court rulings in this regard, we just have to look at the regulations. And in Europe, we face the problem that this is a reproduction, and in general, we can say, well, this is fair use. So people or researchers in the US have slightly a bigger field to play with. So, okay. This is the conclusion for this. This is the first it depends that you will get. Like I said, can vary depending on the jurisdiction. Reproduction during the training process could potentially infringe copyright, and exceptions might differ as said, that we have fair use. We even for researchers, we can gain a lot of data here, but we have to eliminate that after the research is done. So this would be true for Europe, for example. So you will have to ask your local lawyer about this. So next one, personalization. We heard a lot of things about privacy yet. So what about this? Nothing has changed. Data protection law and AI is still the same. So I will skip this basically. Any personal, any information about a natural person is protected. GDPR has become a global standard right now. Remark, it derived from Canada in the first place. But anyone who can be identified directly or indirectly should be kind of safeguarded by this protection. So this has not changed. This is something that has not changed with AI entering the field. So therefore, we can skip this. Basically, there are some examples where you can clearly see that those students could be easily identified. And if you enter this into a system, that might be a problem. Also, for example, GDPR applies to Europe, but a lot of this stuff is transferred to so-called third country, and there is no proof that there is equally an adequate level of protection there for this data. So therefore, universities are especially keen on keeping those data sets private. But as I know, a lot of universities just don't care. So that's the thing. There's a checklist. If you want to look at this, it's from Deloitte. I just copy pasted that. There's a link. If you want to look into this, there's about transparency, data minimization, and all that stuff that you will have to keep in mind. It's there, so you can have a look. So that's the second it depends that you will get for today. So we have it depends for copyright law. We have an it depends for data protection law. Just to move on with selected prompts for a second, because then you will see what it does. I asked Dali, in that case, create an image where Marvel, Disney, and DC heroes are hanging out at the beach. I know that Disney, Marvel and Disney more or less are the same, but if you look at the license terms, some of that is cross-licensed. Never mind. I asked it to do something, and it said, yeah, well, there are some IP issues, so I cannot do that because they are copyrighted. So that's a good thing, because it keeps in mind that there is a copyrighted, there's IP stuff, but then it created those pictures. And that's kind of funny, because it assures a user that it is aware of copyright, it's aware of IP, but in the end, of course, it was trained using all this IP related stuff. And if you have a closer look, I think Disney might not be too happy if some of us wants to use it. So therefore, please keep in mind that even if the system tells you that it's safe, it might not be. So that's an applied tip that you get. Also, that we asked it, please give me the beginning from the picture of Dorian Gray. And back in the days, it did. Now it learned that this could be a problem, so we still asked it to do it with Harry Potter, and it said, no way, it cannot do that. So please keep in mind that even if the system tells you that it cannot do something, it might still infringe copyright. It also can hallucinate, we all know that, so that I don't have to talk about. But we have a freedom of quotation here that will safeguard you if you don't have fair use in those jurisdictions where you don't have it. Good. So there could be guidelines that we can implement also for our research. So if you tell people the specification of the system that you use, for example, we have now a student group who's working on a game that is 100% AI. We tell them if something doesn't work, we can do research about it, but you cannot use anything that's not AI. If you need to tweak like a line of code, that's okay, but that's it, and you have to document everything. And therefore, be as transparent as possible. That's what I'm going to tell you. So we don't have time for those questions, but you can scan through these after this presentation is over, and then if you have anything to discuss or any insights, we can talk about this, of course. So let's go into a conclusion real quick. Looking at the AI Act that we have, unacceptable risk is prohibited. So anything that we have in social scoring systems, manipulative AI is prohibited. There was a research that just from gaming that like 1,000 people were using their consoles, like their Xbox and PS5, and then the biometric data of the usage was kind of saved. And then an AI system had to find out, just by using those headsets, could you identify the person? And with, I think it was like 5 usages, it was up to 50% that there was a hit, that it could identify the person. With up to, I think, 10 to 20 usages of the system, it could identify the person by 99%. So even though there was no name, nothing given, just how they use their controllers. So this could be something. We have all those high-risk AI systems are regulated. We don't know yet in Europe what high-risk AI systems really are, because that's something that we're still waiting. And the good thing for us is that minimal risk is unregulated. For my industry, video games, it's considered low risk, which I think is kind of funny, because if you look at the knowledge that is in the industry, and that most of the AI systems come out of the industry, that's something that I think is quite interesting. So for you guys, please don't panic. Even though there might be a lot of stuff, we lawyers like to tend to tell people, no, don't do that. But we don't have AI specific standards yet, but have a look. Only general legislation currently applies. Unacceptable risk is prohibited. I told you that all general purpose AI models must provide technical documentation. So if you have something that uses or is kind of installed instead of a human being, then you have to follow those lines. If you are in the US and you are a US-based AI vendor, please have a look at the GDPR regulations. You might want to comply with that. And we don't have robust regulations so far. And it depends, and that's the one thing that I want to leave you with. Even though we lawyers like to tend to say it depends, please don't think it means you should ignore legal implications. It means you need to seek expert counsel, because then you will get, hopefully, up-to-date insight. So this is like work in progress in research terms. If you want to learn more about this, please reach out, and thank you so much for those 15 minutes.
Thank you very much, Professor Ernelli. To be honest, your topic was very interesting. I wanted to listen to it hours and hours. And I just seen you put, don't panic. You actually gave me panic. I'm very worried about the use of AI. It's so complex. And as you mentioned, I'm just thinking now many of the companies are actually using this new model of federated ChatGPT. They even run it on their own system. And if you don't know, it can use some of the resources that might be IP protected, put your company at risk, and you may not be even aware of it. And for the users of those services who might live in different parts of the world, and you might host this service, imagine in a cloud service, could be in China, could be in Mongolia. And I can see it's a very deep and complex legal issue for everyone involved. It's very worrisome.
It is. It's a brave new world.
So do we have any question? I guess there should be many questions. from Kai, so he can inform us with more details. Is there any question online? Yeah, so you just touched base a very important area that universities are really worried about. You know, these new AI models, they're coming up with new models, with new systems, and I cannot think there is really definitive answer to it. It's a very complex area. But would I be able to invite you later for another talk to to give us more information about the legal aspect? Your topic is very interesting, and I know many people are really interested in the type of work that you're doing.
Of course.
Yeah, thank you very much. Thank you. Yeah, sorry again for the short time and the bad time management that we did.
No,
I wish we had more time. We could really enjoy your interesting talk. Thank you again for being with us. Thank you everyone for joining this consumer technology talk series in September. I hope you all enjoyed the talks. Hopefully we stay in touch, and I want you to stay tuned, and we will have very interesting upcoming talks, which Professor Lamberti would share details of it with all members very soon. So thank you again, and hope you have a good day ahead of you yourself. Thank you. Bye for now. Bye-bye.
Bye.